Welcome to myprojectbazaar.com. Now we are going to discuss about the product comparison of feature extraction techniques to classify oral cancers using image processing. Now we are going to discuss about the abstract for the process. Oral cancer starts in the cells of the mouth, that is in the oral cavity. The oral cavity is made up of many parts like lips, tongues, inside the lips and cheeks, heart, plate, roof of the mouth and floor of the mouth, gums and teeth. Oral cavity cancers have been increased in recent years, and each year more new cases of oral cancers are reported. That is considered the capital of oral cancers, with 40% of cancers recorded being cancers of the mouth, mostly caused by tobacco. Hence, this process includes the steps like input, pre-process, segmentation, feature extraction, classification. Hence, these 5 models are implemented to detect the oral cancers present in the image. This is applicable for the datasets, hence the accuracy of the process is justified by the estimation parameters. Hence, this process is more reliable for the oral cavity detection, and then the efficient feature extraction and classification will more efficient to detect the oral cancers present in the oral image. This is the overall flow diagram for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After getting input image from the dataset, the pre-processing is carried out. Pre-processing is nothing but to remove the noise present in the image. To pre-process the image, we use the median filter to remove the noise present in the image. After applying the pre-processing step, the segmentation is carried out. In this segmentation process, we use the morphological process. Hence, morphological is an algorithm to segment the oral cancer region from the other backgrounds. After the segmentation part, the feature extraction is carried out. Here the feature extraction, we have applying the 3 type of feature extraction from the image. First one is the LBP, that is the local binary pattern. Then the second one is the gamma. Then the third one is the HOG, that is the histogram. After applying these 3 feature extraction method, the feature values are extracted from the image and those are concatenated to form the test feature. After generating the test feature from the image, the classification is done by using the KNN classifier. For the KNN classifier, we have to give the 3 input. First one is the test feature, then train feature, then third one is the target. After giving the test, train and target as an input for the classification result shows whether the input have the cancer or not. After the classification, the estimation is done to justify whether the process is efficient or not by using the parameters like accuracy, sensitivity and specificity. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code, means just right click in the oral cancer detection.m and select the option run. Now the initial GUI design was opened. In that you can see the several push buttons to control the axis and then the axis to display the image. Now click the button load image. After clicking the button load image, the dataset folder was opened. In that you can see the several oral images and select any one image from the dataset. After the selection of the dataset image, the corresponding image is shown in the axis 1. Now click the button image pre-processing. After clicking the button pre-processing, and the enhanced image is shown in the subplot. The grayscale conversion is nothing but to convert the RGB channel into a single dimension. Then the image enhancement, we have to boost up the contrast regions and we have to stabilize the pixels. After the image enhancement, we can apply the local binary feature extraction. Hence, this is the image for the pattern extracted from the image, and the corresponding values are saved as an LBP FIA. Then click the button HOG feature extraction. After clicking the button HOG, the histogram values are extracted from the image and then saved. Then click the gamma correction. Now the gamma corrected image is shown in the figure 3. Hence this image values are extracted as an feature values and then saved separately. Now click the button feature extraction. After clicking the button feature extraction, these three values like a local binary pattern, HOG and gamma correction values extracted from the images are extracted and then concatenate together to form a test feature. Then click the button classification. After clicking the button classification, the KNN classifier panel was opened. Now click the button KNN classifier. Now the status of the input is shown in the edit box. Hence the input image is not affected. So in the edit box, the message is shown as an not affected. So at last the classification, the estimation parameters are estimated and then plotted in the graph format. Hence the comparison chart between the SVM and KNN is shown in the figure 10. Then the figure 9 shows the sensitivity for the existing and proposed. Then the comparison chart between the positive predictive value will be shown, and then the comparison graph between the accuracies between the SVM and the proposed method is shown. Hence the existing and proposed value for the accuracy, sensitivity, specificity and the positive predictive values are shown in the bar chart format. And finally, the values for each and every accuracy, sensitivity, specificities are shown in the tabulated format. Thanks for watching this video.